Okay. Very well. So we're on the second example before the first 45 minutes expired. So we want to still take the sample. The network is disturbing a bit, but I think we can do this one. So 2, 1, and then 3. Let's have 3 here. And let's take B to be the matrix 1, 2, or make -2. Let's have 3 and then 2 here. So if you want A times B, like we said earlier, it's going to be row times what? Column. Okay, so you pick the row, first element in the row, times first element in the column, the first element, second to second. Okay, so that will be 2 times 1 plus 1 times -2. Then once you are done with this column, you go to the next column. So it should be 2 times 3. Okay, 2 times what? 3, and then 1 times what? 2. Okay, so that will be 2 times 3, 2 times 3 plus 1 times 2. Then once we are done, we have to go to the next row and repeat the same process again. So it's going to be 3 times 1 plus 3 times -2. Okay, this is 3 times 1, 3 times -2. Then once we are done with this column, you do same for the next column. So that will be 3 times what? 3 plus 3 times what? 2. Okay, then we can simplify. This will be 2 times 1 is 2, and then 2 times -2 is -2. So 2 minus 2 will be 0. Then we have 3 times 1 is 3. 3 times -2 is -6. So 3 minus 6 will be -3. And then we have 2 times 3 is 6. Plus 1 times 2 is 2. So 6 plus 2 will be 8. Then we have 3 times 3 is 9. Plus 3 times 2, which is 6. When we add, that should give us 15. Okay. Good. So this completes our second example for multiplication of matrices. Please inform those who are off the page that the class is still ongoing. Tell them the class is still ongoing so that they can quickly join. I'm about introducing the next item, which is very important for your examination. So inform them class is still going on. They have to join. Okay. Now let me clean part of the screen. The next thing we want to look at is some properties, okay, of the matrices, or what we refer to as the determinant of the matrix. Okay, good. Now, when it comes to the determinants, the determinant, which is usually written as debts, determinant of, let's say the matrix is A, so debts of A are also denoted as, okay, we have 2 bars with the A in between, and that gives us the determinant of the matrix. Good. Now we'll be looking at the determinant of a 2 by 2 matrix and the determinant of a 3 by 3 matrix. Now for a 2 by 2 matrix, like what we have here, A and B, the determinant is quite straightforward. It's just, and I want to avoid all formulas, okay? We just want it to look very simple. So the determinant usually is these 2 elements, okay, in the leading diagonal, 2 times 3, okay, minus, so it will be 2 times 3 minus this other 2 multiplied, okay, that will be 1 times what? 3. So that will give us 6 minus 3, which will be equal to 3. So that is the determinant of the matrix A. The same way, the determinant of the matrix B will also apply the same, okay, principle. That will be this times this. So 1 times 2 is what? Is 2 minus 3 times negative 2 will be what? Negative 6. So minus negative 6. So that will be 2 minus will be plus. So that should give us what? Positive what? 8. Okay, for the determinant of matrix B. Okay, so that does it for the determinant of a 2 by 2 matrix. Now, what about a 3 by 3 matrix? Okay, it's also very simple. It follows almost the same logic, just the introduction of 2 other terms. Okay, so yeah, let's take a 3 by 3 matrix. So an example of a 3 by 3 matrix will be, let's say, the matrix C, which is where is this thing? So which is 2, let's say 3, 1. Then we have 3, negative 5, and then we have 2, and let's have 1, 1, 2, and say 3. Okay. So if you want the determinant of this matrix, what is going to happen is we need what we call as the cofactors. Okay, we have what we call as cofactors and minor matrices. Now, this is what we do this is what we do. You're going to select the elements, okay, up here, 1 by 1, and then we are going to create what we call as minor matrices by deleting their corresponding row and column. Okay, this is how it will be done. So first, let's write the elements 2. We have 3, and then we have 1. Then the next thing is when we pick 2, you delete the column on which it is and the row on which the 2 is. Okay, that forms a 2 by 2 minor matrix, a smaller matrix. Okay, so that will form a smaller matrix, which is what? minus 5, 2, and then 2, 3. Then we go to the next one. Good. Because this time we are picking 3, you delete this column and this row, and then we form a smaller matrix, a minor matrix. 3, 1, 2, 3. The next, when we select 1, we are going to delete the column of the third column here. So the minor matrix will be 3 minus 5, 1, and then 2. Okay. Next, we need to understand the cofactors has a formula, okay, of doing that. Now, the formula is -1 raised to the power the row number plus the column number. Okay, good. But this, I mean, the sign of the cofactor. But we just have to know for element, or let me put it, row 1, column 1 means that your row number will be 1, column number will be 1. So 1 plus 1 will be 2. -1 raised to the power 2 will be +1. Okay, so we usually have this sign table: negative, positive, negative, positive. In the next one, it's going to be negative, positive, negative. Then once again, we are going to get positive, negative, and what? And positive. Why? When I pick this element here, this is row 3, okay, column 1. So 3 plus 1 will be 4. -1 raised to the power 4 will be positive. Okay, so that is how we get the signs. Good. Now, because this 2, 3, and 1 fall within this sign pattern, would bring the signs that precede it, okay, in the sign matrix here. So we have plus, this is minus, and then this will be what? Plus. Okay. Yeah, just to make it very simple for us. Okay. So once we've achieved this, you just find the determinant of the minor matrices, which we've already looked at. Okay, that you multiply this by this, and then subtract this from that. Okay, and the product of this from this. So this will be what? This will be 2 times minus 15. This will be -15. Okay, minus what? 4. Then next we have minus 3 into bracket 9 minus what? 9 minus 2. Then we have plus 1 into brackets 1 into bracket 6 minus what? -5. Okay, so this will give us 2 times minus 19, then minus 3 into bracket 7, then plus 1 into bracket +11. Okay, so as you can see, this will give us what? Minus what? 38. Okay, minus 21 plus what? 11. Okay, which will be negative 48. So that will be the determinant of our 3 by 3 matrix. Okay, now to the last but one thing, which is also going to make use of the concept of what determinants. Okay, good. Now we are going to look at what we call as the Cramer's rule. We are going to look at the Cramer's rule. And I'm not taking a second example because the Cramer's rule will also make use of the determinant again. So it means we'll be solving more examples of the 2 by 2 and the 3 by 3. Okay, good. Now, what Cramer's rule says, let me just write it. So the Cramer's rule okay, what it's saying is if I give you a system of equations, let's say 2x plus y is equals to 3, and then x minus y equals to, say, 2, and I ask you to solve it. Cramer says that it's very simple. We can make use of the determinant. First, you will need to express the system of linear equation in the general form. Okay, the general form is always ax is equals to b, where a is the coefficient of your x and your y, and then your x are the unknown in the equation, that is your x and y, and then b is your solution, the values after the equal to sign. So in this example here, if we are to express in the general form, coefficients will be what? The coefficients of x and y will be 2, okay, 1, and negative what? 1. Okay, then the unknowns here are x and y, and then the solution matrix is what? 3 and 2. Okay, so we've written it in the general form. Okay, now this is what Cramer says. Cramer says that first find the determinant d, okay, which is the determinant of the coefficient matrix, which will be the coefficient a. Then second, you are going to find another determinant we call as dx, okay, which is the determinant of the original coefficient matrix, but this time around you replace the component of the x with the solution. Then finally you find dy, okay, which is also just like the dx, replacing the y component with solution. Very good. Let's see how it works. So if this is what Cramer is saying, then first we find determinants of a. So we find d. D will be determinant of what? 2, 1, 1, and negative 1. This will give us what? 2 times minus 1 will be what? Negative 2. Okay, minus 1 times 1 is 1. So we get minus 3. Step 2, we have to find dx. Okay, now to get ds, we said you need to replace the s component in the a. You see, these are the s coefficient, the coefficients of x in the original equation, 2 and 1. And these are the coefficients of y. So we'll replace the coefficients of x with the solution here. So this will be now it will become what? 3, 2. Okay. Then you find the determinant of that resultant matrix. So the determinant now is going to be 3 times 1, which is minus 3. Okay, minus 2 times 1, which is what? 2. So this will give us what? This will give us negative 5. Then finally we have dy. So dy is going to be, we are going to replace, this time you are going to replace the coefficients of y in the original matrix with the solution. So we have 2, 1, and then we replace the y. That will be 3 and 2. So let's find the determinant. That should give us what? 2 times 2, which is 4. Okay, then minus what? 1 times 3, which is 3. So we are going to get 1. Okay. Then once we are done, we can find our x. Our x is just given by dx, determinant of ax, over d, over the determinant of the original matrix. So that will be what? Negative 5 over negative 3, which is 5 over 3. Okay, so it means that x is what? 5 over 3. Okay, which is 1.333. And then your y will be dy. Y is dy over d. Okay, so that will be 1 over what? 1 over minus 3. So it means that dy is what? Negative 1 over 3. Negative 1 over 3. Okay. So that gives me negative 1 over 3. Okay. Any question on the solution so far? Any question? If there's a question, please raise up your hand and ask. Okay. So in the absence of questions, we'll also look at the solution for a 3x3 system, which is just an extension of what we have just looked at. So assuming this time I have a 3x3 matrix, let's take a 3x3 system. So that will be maybe 5x, okay, plus say 2y plus 3z is equals to 7. Then we have x plus 4y plus z is equals to, let's say, 5. And then finally we have minus 2x plus y plus 3z, okay, is equals to, say, 4. And we are supposed to solve this system of linear equation. First, we said you need to write it in the, okay, we need to write it in the general form. So coefficient matrix, we have 5, 1, -2, 2, 4, 1. We have 3, 1, and then what? And 3. Then we have our x, y sets. We have x, y, and z. Then we also have the solution, sorry. We have the solution, which is 7, 5, and 4. Okay. So you follow the same steps. So here you're going to find d, you find dx, okay, dy, dz, okay. So to get d, d is just the determinant of the 3 by 3, the coefficient matrix A. So d is going to be the determinant of what? This matrix here, 5, 2, 3. Then we have 1, -2, 4, 1, 1, 3. Okay. So maybe you can be thinking about that whilst I write for dx, dy2, okay? Or you can be solving it from your head. So ds means you replace the x coefficients with the solution. So that will be 7, 5, 4. And the others remain same. So 2, 4, 1, 3, 1, and 3. So next will be dy. dy is, so dy means you replace y. These are the s coefficient, y coefficients, z coefficients. So we are replacing y. So x remains the same, 5, 1, -2. Then you replace y with 7, 5, 4. Have 3, 1, and 3. Okay, good. Yeah, so like we said earlier, this is going to be what? 5. Then our minor matrix, once we pick this will be the minor matrix, right? So we get 12. 4 times 3 will be 12 minus 1, which will be 11. Then don't forget the next sign will be, when we pick 2, it will be negative. Somebody should go. Okay, so we have 2. Once we pick 2, we have the minor matrix will be, when we pick 2, is going to be 1 times 3. 1 times 3, okay, minus -2. So that will be 1 times 3 is 3, minus -2 will be 5. So this will be 5. Okay, then the next one will be, when we pick 3, so that will be plus 3. Once we pick 3, we have the minor matrix will be 1 times 1, which is 1, minus 8 will be 1 plus 8. 1 plus 8, which is going to be what? So that one is going to be 1 plus 8, which is going to be 9. Okay, so this is going to give us 9 here. Okay, so once we compute that, that will be 55 minus 10 plus 27. So I'll be expecting the answers from you. Now the same thing we'll do same here. We'll pick, first you pick your coefficient. So we have 7, okay, 7, 2, and then you have your 3. But we know 2 is going to be negative. Then your determinant of the minor matrix will follow. Okay, so I want you to do that for me at your end. Then the same thing too here. When you come, you pick 5, 7. 7 is the second one, which will be negative. Okay, and then 3. So you have this, and then you have this. Okay, so once you pick 7, okay, the minor matrix is 4, 3, which is 12, minus 1, which is 11. Then once you pick 2, the minor matrix is going to be what? Once you pick 2, the minor matrix will be, okay, 5, 3, and then 4 and 1. So that will be 15 minus 4, which will also be what? 11. Then once we pick 3, that is going to be, once we pick 3, yeah, so we are left with 5, 4, 4, 1. So that will be 5 minus 16. 5 minus 16 will give us what? Negative 5 minus 16, so negative 11. Okay, good. So you do the addition from your end. I'll be expecting the answers. Okay, so please work the answers out and type it for me. The same here. Once we pick 5, our minor matrix will be 15 minus 4, which is 11. When we pick 7, just a minute. So when we pick 7, minor matrix will be 1 times 3, which will be 3, minus 2, which will be 5. Then finally, when we pick 3, okay, we have 1 times 4, which is 4, then minus negative 10, which will be 4 plus 10, which will be 14. Okay, then we are not done. You have to do for the z also, don't forget. So we will need to find dz2. So you need d of z. So d of z will be that you have to replace the coefficient of z. So that's 5, 1, minus 2, 2, 4, and 1. Then you replace the z component with 7, 5, 4. Okay. And find the determinant. So that will be 5, okay, minus 2, 7. Then you find the minor matrices. Here, when we take this will be what? 4, 4, 16, minus 5, which will be 11. Then when we take 2, over here. Oh. when we take 2 here, we have 4 times 1, which is 4. 4 minus 10, which is going to be 14. Okay. And then finally, you have, when we pick 7, when we pick 7 here, okay, we are left with 1 minus 8. So that will be what? 9. Okay. So once you find the answers, then next if you just want your solution, x will be the dx you obtain here, the value you obtain here, over the d. Your y is going to be your dy you obtain here over the d. Then the z will be the dz you obtained here over the d. Okay. Yeah, so finish up the solution at home and let me have your answers, okay, for this particular question. Okay, so take note of the question, finish it up for me, and then you send me the complete solution. Okay, so complete the solution at your end and then send them to me. Now, like I said, I wasn't going to take too much of your time for today. I know you're already revising for the examination. I wanted to make sure that we can all score an A+. Okay, the examination is going to be in 4 parts. We have 4 various questions. Okay, the first 2 will be on the statistics parts, which we've been looking at so far in class. Okay, then the next 2 will have a full question on matrices, what we have just done in class today, where you use the Cramer's rule to find the solution, okay, to a given system of linear equation, and also to find the determinant of a 3x3 matrix. Okay, so that is a full question, 20 marks on its own from today's class. So which means that with that, you should be able to score 60 over 60 in examination. And I'm very confident that as for the first part of the course, you are okay, but we do not want to be complacent. Okay, don't be complacent. Now, this is what we'll do. We'll meet for the last time, okay, somewhere next week before you write the exam. So take notes. When I call an online class, please try to be in class. Very, very important. Don't be complacent that this time the course is okay, so that's all. You are not attending lectures. Please attend the lectures. Now, let me take 1 or 2 comments if you have, because my time is almost up. The Zoom class will end in the next 1 minute. So if you have any comments, you can bring it up.